All right, looks like we're ready to start. Hi everybody, my name is John.
And I'm Brian.
And we're going to talk to you today about IOC in probably a slightly different way than you're used to it. We're going to be talking about doing IOC in JavaScript. So who are we? We're both JavaScript fanatics, fans, which is great, but one thing that's different and maybe will help justify our existence to you is that we both started out as server-side guys, back-end guys doing the back-end work. So also interesting to note that we're the two main characters behind Cujo.js, which of course you're now saying, what is that? Actually, you may have heard it in some of the presentations today, and Cujo.js is really what our experience said, well, what's missing with JavaScript? We're trying to use it. We became fans. We actually learned to like JavaScript, but it was missing a lot of things that we're expecting to. And so, but at the same time, we're not porting Spring over to JavaScript. So if that's what you're expecting, you're not going to get that today. There's actually some really nice features in JavaScript, and we embrace those and try to use those. So, but what it boils down to is basically, Cujo is a collection of what we like to call architectural tools and patterns you can build on top of that for JavaScript, and specifically aiming at next-generation JavaScript applications.
And while it's not a direct port of Spring, when we show you code examples, hopefully the idea is that your experience with Spring will help you recognize a lot of the things that you'll see in the code examples.
The bad news was that we have tons and tons of material because we can't obviously cover all of what the ecosystem of IOC is in an hour and a half. The good news is that we just chopped out 27 slides for you guys, so that should be good. But at the but again, the bad news is that we cut out all the jokes. So there's no more jokes in here. And to help move this along, we love questions. Actually, we love to interact with you guys, and we want to hear from you guys if we're doing something wrong. But we do ask that you do that during the code demos, which we're going to have a lot of actually. So save your questions for the code demos, but please do ask them, or just save it for the end because we should have a little bit of time at the end to discuss things. So. Where this all started, like I said, we came from a more architectural background than most JavaScript developers, and we ended up in our roles where we're expected to deliver these huge projects that are basically all in the browser. This is a recent example Brian and I both worked on about a year ago. There are only 6 HTML pages in the entire app, but there are over 300 JavaScript modules at the time. And a lot of those were just views, which of course views are comprised of HTML templates, CSS files, some language translation files, and then of course we had test harnesses go along with it. This application is actually much larger now that we've moved on, and they've continued to build onto this application. So at this point, obviously, in JavaScript, you've seen people do it. They just kind of like glom all their code together into a couple of big files, and dependency management at that point is obviously just not even feasible. And in general, just trying to figure out how to build an architecture around something that's just a big mass of code is tough. So Brian said this best. Actually, Brian's going to say a lot of things better than I can. That we obviously need to have rigorous architecture patterns and code organization in our front end, or this whole thing's just going to fall apart. And so I'm going to hand this over to Brian and let him talk a little bit about what we did from there.
We kind of know this from Spring, right? This is how Java has evolved over time. As we build bigger and bigger server-side applications in Java, we learned that we need these patterns, or the thing just kind of caves in on itself. And Spring has done a fantastic job of allowing us to use those patterns. It's captured them, given us a language for expressing them, and as we build larger and larger JavaScript applications, what we're seeing is that we need these same things, right? Script tags, 27 script tags in your HTML file is not enough anymore. Like John said, one giant JavaScript file with all of your functions at the global scope is not enough anymore. And not only that, we're not only running in the browser these days, we're running on the server too with Node.js, other server-side platforms like Ringo, even Rhino. So we're spanning the client and server now. The server side's going to get larger too. So we're going to need these patterns both in the browser and on the server. And some of the things we would like to be able to do that we learned from Spring, the most basic things is, can we split an application into smaller pieces, modules that are easy to manage, easy to refactor, easy to test, and then glue it all back together, like Spring lets us do with application contexts, in a way that's loosely coupled, maintainable, all those things we love, into a running application that runs in the browser or on Node on the server. And, all the things we love about Spring, can we get those in JavaScript? And if we could, what would it look like? Right? Would we want to write XML for that? That doesn't really fit with sort of the ecosystem of JavaScript, which is built around leaner libraries, leaner tool sets, an interpreted language. It's quick to refactor. Switch to your browser, hit Command-R or F5 and see your changes. And everything feels a little lighter in JavaScript. So what can we do in JavaScript to give us the same kind of functionality, but not use things that don't fit well with the JavaScript ecosystem? So XML, probably not. Annotations, they're very convenient in Java, but there's no infrastructure in JavaScript for that kind of thing. So can we work with the language? And the answer is, we believe, yes. So what I'm going to do is just jump right into a big example that's going to be an overview of a lot of things you're going to see, and walk through it. And hopefully a lot of the things that you see here are going to resonate with your experience with Spring, but also give you some insight into how these things can be done with JavaScript. So without getting into too much detail about things like this define up here that's wrapping this whole thing, what we're looking at is essentially JSON, or a JavaScript object literal. Okay, if you're familiar with JavaScript, you've seen this kind of thing. And this is a description of an application written in a simplified form that is similar to a Spring XML application context, but it's written in JavaScript object literal notation. So you've seen this application before. If you came to the keynote on Tuesday night, you've seen this Monty Hall problem application where you pick a door.
So should we stay or switch? Oh. Brian knows the secret.
And if you win, you get Jurgen. But that application was assembled using an IOC container called wire.js, which is a part of Cujo.js. And it uses this simplified sort of description language that's based around plain JavaScript. So if I just sort of go through this, you'll see some things that start to make sense. Like we have this component, its name is marquee view. This is like a bean ID equals marquee view, but we just give it a name, marquee view. And we're rendering some HTML, and this is actually the title, the Let's Make a Deal title at the top. We've got another view here rendering some HTML into the page. This is the instructions view. It appears at the bottom. But more interestingly, we have a JavaScript component here called controller, and we're creating something. This is actually a JavaScript module. We'll get into what that looks like, but just know that there's some JavaScript component that we're creating an instance of. And then we're configuring it. We're setting some properties on it. Very much like Spring. We're doing dependency injection, right? And we've got something that looks like it might be a reference to another component here. And if we scroll down, you'll actually see there's another component down here named Game API. So we've got some configuration here with declarative dependency injection. We've got this on thing here, and it's referencing something called doors view. And this kind of looks like it might be related to a DOM event, right, a click event. And this kind of looks like CSS selector notation. So
this doesn't look like Spring anymore. Sorry, go on. You're losing me, so.
So we're actually hooking up some DOM events here, and we'll get into what that means and what that looks like. So not only are we doing dependency injection, we're actually hooking up things to the DOM here without going into the JavaScript code and doing it there. And we've got this. What is this? This kind of looks like AOP after advice, but it's after resolving. What does that mean? It is AOP, so you're going to see how we use AOP to do some of this stuff in a loosely coupled way. We'll get into what the after resolving means. If you've done any JavaScript programming at all, you know that JavaScript is highly asynchronous. So we need to find ways to deal with that asynchrony in a declarative manner like this. So we'll see how something like this helps. And then we've got this ready start game. That kind of looks like it kicks things off, and indeed it does. So what we did here is we've created the game controller, we've configured it, and we've set the whole thing in motion by saying that when this application context, if we want to call it that, is done and ready, we're going to call this start game method on the controller. So this is kind of an overview of what it might look like to assemble this application using something that's JavaScript-y, but yet transfers a lot of the concepts that we know from Spring are going to help us, like an application composition layer and a language to express it. So I'm going to hand it back to John, and we're going to start talking about this right here, which you heard we mentioned that we need to break this application into smaller pieces, and one of those pieces here is this JavaScript controller that's driving the game. And how do we package that up in a way that we can create instances of it, keep it self-contained, even load it as needed?
Thanks, Brian. So one of the things, if you've been to some of the other client-side tracks, you may have heard this term AMD thrown around, and we're not talking about the microprocessor. We're talking about a standard, a proposed, it's not an official standard, but it's more of a community standard within the JavaScript community, and it's called asynchronous module definition. Asynchronous because JavaScript is single-threaded, and therefore everything we do, we need to just send out a request and keep continuing on the client until the response comes back. And of course, module definition, I think that makes sense. So we need to create this definition of what an atomic unit of JavaScript looks like, but it also needs to be asynchronous. So there's three main parts to that. There's the actual module format that we're going to definitely get into today. There's a runtime loader that needs to understand that module format and needs to be able to do things like know when it's already got a copy and when it needs to go fetch a copy and where it needs to fetch it from. and a build time compiler component as well, because you don't want to do a million fetches during in an application because of the overhead of all the HTTP. So and there are actually a couple of formats we'll look at them. AMD was specifically designed with the browser in mind, and not just the asynchronous part, but also you'll see just by the format of it, it's very much in tune with current JavaScript, not just next generation JavaScript. So. And in particular, this allows us to do things without having to parse anything, and it's also got some built-in advantages like a closure and the ability to let us grab other things asynchronously using the same mechanism, and that's where the plugins come in. So it's actually very widely supported already. Dojo's been supporting it for. Actually, it was modeled after some work that Dojo had done. Of course, our library supports it. jQuery has been supporting it since version 1.7, which is well over a year now. MooTools, there's lots of other small libraries out there. You may not even know it, but they have AMD support in them. So it all comes down to really one global function, and that's the define. And I'm sure you've noticed that in Jeremy's and Scott's and some other presentations here. So this is like the gateway to the gated community. Everything inside this define statement is where we fall into this standardized environment. So all your code that's inside a define can always expect to work correctly in an AMD environment. So,
and the reason the define is sort of necessary is, as you know, if you've worked in a browser, it's just kind of a free-for-all, right? Everything's global by default. So one of the sort of geniuses of AMD is that by wrapping it in this define, you can protect the module at least a little bit from sort of the global hackfest that's outside of the define.
We don't actually block the global scope, but it also just encourages you to, and makes it brain dead easy to write your code in a non-global scope. So, and there's two main flavors. I'm lying a little bit, but let's just concentrate on two main flavors, and that is you either supply a factory function to define, or you supply a list of dependencies and then a factory function. Just dive right in and take a look at that. So this is the standard AMD, and this is the first version that came out before it was even called AMD. So here's an example right here where we want to grab this module named when, and another module that looks like it's part of a package that's called package/mod. And as you can see, both of those are mapped over to parameters to the factory function. So what happens here is that these modules can be fetched either synchronously or asynchronously. It doesn't matter, but all you know is that by the time your factory function executes, they're available to you. So, and of course, the important part with the standard AMD is that you return something from this factory function. So, and that becomes the definition of your module. There are lots of variants because, of course, everybody's doing everything in every which kind of way you can think of in JavaScript. So there are several variants, and I'm going to go over the most important ones that at least we think they're the most important. Here's how many people are familiar with commonjs? Okay, another community-driven standards organization. It's not the official ECMAScript, but it's a very strong and very influential sub-community within JavaScript that's helping define standards. You're going to hear us talk about commonjs a lot here. And commonjs defines a different type of module that we'll look at it in a little bit more detail. But it doesn't have this factory function surrounding it. So what we're looking at here is an AMD wrapped commonjs, and so we're going to talk about how we can get a lot of things to run inside inside AMD, and this is just one example here. So the key to this one is that there are actually no dependencies, but there are parameters to the factory function. And AMD sniffs this and said, oh. This must be a CommonJS wrapped, and it will automatically provide these up to these three parameters require exports in module. Because these are, as we'll see, these are the cornerstones behind the CommonJS format. So in here, this is similar to like an imports in Java. We can actually go and require other modules. So for instance here, we're requiring that module when that we were requiring up in the dependency list before. And with CommonJS, we have this exports object, and we basically decorate that, and that just automatically becomes our module. So we just add properties to this exports object, and we don't have to return anything from a factory function. That is basically the manifestation of the module. There's another variant that is very similar to CommonJS. It's actually an extension to CommonJS, and this is node specific, but it's also supported by Ringo and possibly some other CommonJS environments. But this is not officially part of the CommonJS specification. And specifically, I'll go over this again, but there's a slight difference in how you can actually define your exports, and that is you can actually assign to exports instead of decorating this predefined exports object. So. Then, of course, people wanted to be compatible. They want to write their code once and not have to wrap it or in a build step. Yet another module format was defined. I'm trying to think of the XKCD comic where yet another standard was created to engulf all the previous standards, and that's what UMD is. So, and we'll look at there's all sorts of combinations of UMD to, it's a little bit of boilerplate you can put either in front or behind your code to make it compatible with a lot of different environments, including just legacy global environments. AMD and CommonJS at the same time, AMD and Node, which is our favorite, AMD plus Node plus globals, and the list goes on and on. So this is our favorite right here, using the AMD plus Node. And again, it's not just Node. It'll run in Ringo. It'll run in several other environments that have the Node extensions. And basically, here's what it looks like. We basically just have a closure, and then we're going to inject a define function into this closure. So then our module in here looks exactly like AMD. So if you're not familiar with an immediately executed function expression, this is the part down here that actually does the injecting of the defined parameter at the top. So this is the standard and accepted sniff for figuring out if you're in an AMD environment. Is there a function called define, and does it have an AMD property? Technically, that property is an object, but we just consider this enough of a duck type in order to determine if we're in the right environment. So if we're in the right environment, just use the define that was provided by the AMD environment. Otherwise, we're going to assume here, and again, this is a form of UMD that assumes we're in one of two environments, either a node-like CommonJS environment or AMD. We're going to just on the fly create a factory create something that executes our factory function and does what we saw before, and that is, assign an exports object that will be used as a module throughout the rest of the system. So let's take a quick look at this in action. I'm going to switch back to code, and this is not my editor. Let's see how I do. I'm doing fine. I thought I was. Yes, okay. So here's an example right here. This is the game controller for the Monty Hall application. And as you can see, we have that standard closure at the top, and at the bottom we have also some boilerplate. And actually, this is a little bit different. I didn't notice this before. The one I was showing in the slides did not have dependencies. So this is yet another variation on UMD. This one actually is extremely similar, and we actually use this one a lot. So this one changes things a little bit down here in that we're injecting the require here. There's actually an error here. I'm going to fix this on the fly. I don't think we're using much. We are. Well, okay. So this This won't work in Node right now, so this is broken. But anyways, this works in AMD, and we saw it working on the screen, so that's cool. So, but in particular here, what's inside from line 4 down to almost to the end is basically what would look like a CommonJS module. So here we can see where we're requiring something called when, and we're actually exporting an object with lots of properties and functions. So we'll go over a little bit of this later. And the export stops here, and here we have a private function called private in scope, so that we can hide a lot of stuff in this closure here. Yes?
The underscores, do they have a meaning?
Underscores have no meaning except to us, the programmer. Yeah, no, underscores don't have any meaning. We use scopes to hide things. So
We were just using them to designate private functions on the exported object.
yeah,
Methods you shouldn't call.
yeah, it means don't touch me. Yeah, unless you know what you're doing. So okay. All right. So the other global in AMD, and this is not really part of the standard. It's an optional part of the standard to have this other global. Of course, you need some other global to bootstrap stuff because of just the way the JavaScript works. You need something out there to grab hold of and just start doing things somewhere in some script somewhere. So in the Cujo world, our AMD loader is called curl.js. So we have a global called curl. And require.js, the first and most popular AMD loader, the global is called require.js. And a lot of them expose this thing called require, this global function. Require.js declares both require.js and require. Dojo exports something called require. I think MooTools also exports a couple of different things plus require. Curl doesn't by default expose this require object, and the reason is that lots of noobs make mistakes. If you saw back in our code example right here that there is a way through AMD to grab this require object, and that is actually the right way to do it. But if you forget to include this dependency, you end up using the global one, and of course if you're trying to look up modules that are in relation to your module, you end up getting screwed up and not being able to figure out what's wrong with your code. So it's something that we actually have people turn on in curl. So, but of course that require object at the global scope works fairly similarly across your environments. There's a certain subset of functionality that they all provide. So let's take a look at run.js. This, as I said, this is the file that bootstraps our entire application. And I've created a nice little closure up at the top to keep my scope private here. And we're actually, it's a little bit redundant, but we're making sure we're grabbing the global curl here and just injecting it just in here. So I'm going to just go through this really quickly. So an AMD environment needs some sort of configuration to make sure it knows the rest of the world around it. So we're going to provide this configuration to it that says, here's where you're located on the web, here's where you can find things, and here's how to look up all these modules that people are trying to use in their code. So for instance, we need to tell it, okay, all right, so maybe the page is one place, but here's where we put all the code over here. That's what base URL does. We have, this is a curl only feature. This is plugin path. This says, where do I find all my plugins? We'll look at that a little bit closer later as to what a plugin is. But then we've got paths and packages. And paths and packages really are what tells the AMD loader where to find things. And this is standardized syntax across the loaders right here. So paths just say, if you see anything called sizzle, really this should be over at libsizzle. So when you're trying to actually fetch that module, go find it under libsizzle. Packages are a commonjs invention, and they're basically just families of modules that work together. And we've configured several of them here. I'm not going to go through all of them, but basically say, okay, I have a name of a package. It's located in this location, and it also has a main module. And a main module is basically the module that's loaded when you just specify the package name itself. So if I just ask for when, it really is going to go find when/when, and that is the actual module it's going to return. But if I wanted to, for instance, pull back when/delay, which is another module in the when package, we could specify when/delay, and this information right here is enough for it to go figure out where to find that. So we're heavy advocates of using shims to shim the browser environment. So this prevents us from having to have an abstraction level over everything, and provides a normalized environment to write our code in.
If you're familiar with ECMAScript 5, all the nice array functions, array.forEach, array.reduce, those are part of the ECMAScript 5 standard, which not all browsers support, like older versions of IE. So we use shims to provide that functionality so that you can use array.forEach, things like that.
So all this line does down here is say, ensure that this is loaded first. And actually the way that the AMD loader works is it actually is fetching everything in parallel. It's just making sure to execute these modules in the right order. So, we'll look at that a little bit more, but that's that's one of the keys behind AMD is that you just grab everything as fast as you can, and then just execute things in the correct order. And that's easy to do because once we're specifying all the dependencies in the list at the top, that becomes really easy to do. And this last line is just, okay, let's bootstrap everything. We're going to use curl, we're going to configure it, and we're going to wire our application, our app/main module. And so given all this information we've got here, curl knows how to go find app/main. And wire actually here is a plugin. This is a standard notation, plugin, bang, and then some sort of resource ID. It doesn't have to be a module ID, actually. It can be just about anything, depending on what your plugin understands. So basically, we're just saying configure curl, and then go execute this main module. And obviously, main module here gets everything else kicked in. So that's it. Okay, so just quickly on AMD plugins. Again, they use the same dependency mechanism. Let's use this great parallel, non-blocking, really fast way to grab modules, and let's use it to grab other things. Let's go grab some HTML templates. Let's grab some CSS files. Let's grab some JSON. Let's use this as a way to make Google's APIs work the way we want them to work. So, and then we got some advanced ones. I just showed you a quick little example of wire. This is how we can basically take one of those specifications that Brian showed earlier and go grab it from somewhere and then process it. There's other ones out there for loading CoffeeScript and some other things. And there's one that also lets us do feature detection, and there's some really elaborate ones out there. I can't go into all of them. So let's take a quick look at some other. That's not it. Yeah, here we go. Okay, so just quickly, since Wire understands AMD syntax, we can also use these in our Wire specs. So here's an example right here. We're grabbing a theme CSS file using the CSS plugin, and the way this works is that after this, even though this looks very module-like, and you'll find that lots of plugins use very module-like syntax because that has advantages because then the loader can do some things for the plugin. This is really just anything back here, and the people who have written some of the Google AMD plugins, that's just like version number colon something version API / whatever. But anyways, the plugin basically takes over at that point and says, I know what this is, I know how to get it, and it goes and fetches it, and it uses the same mechanism. So here's an example right here of using the text, the text plugin, and it's just pausing there because I was thinking these are actually somewhat standardized plugins. There's a certain subset that just about every loader has, and that is they all have access to something that's CSS. They don't all have them by default, but you can go out and find them on GitHub. They all have a text plugin, and they all have an internationalization plugin. So, and basically the way the internationalization plugin works is it tries to sniff the locale that the current user is in, and then use that information to try to go out and find the correct version on the server. And of course that can be over a remote link. That can be kind of a hit or miss process. So ideally, you're building your modules all into larger files, which is something we're probably not going to get into too much today. But that internationalization piece, you can actually build versions. You can build a French version. You can build a Parisian French version. You can build a Chinese version. You can build whatever version you want. So you'll see these sprinkled out throughout our demonstrations today. So just remember that if you see the bang, that just means we're invoking a plugin to do the loading. So yes, I mentioned CommonJS. With CommonJS, every file is basically a module, and that it's really simple. And there are three things that are injected into the scope of the module, and we call them free variables because nobody wanted to call them globals. And they're actually not really globals because they're actually different for every module. So we call them free variables, and that's the require and exports and module variables that we saw before. Require is just a simple way to go fetch a module. Exports, like I said, is a way to define your module. And module, the module variable itself just has extra information like what's the URI, is there a unique identifier for this module? And that's really mostly just edge cases that you'd need this stuff, sort of meta programming and stuff. So we love CommonJS, actually. I should say CommonJS modules. We love all of CommonJS, actually. And we're advocates of a concept called compile to AMD, and all the AMD loaders do this to a certain extent, but we're really gung-ho on this whole transpiler movement in JavaScript to take all these different languages and transpile them to JavaScript. Well, we're taking that one step further and saying, whatever language that is, let's build a plugin around it and use that transparently so you never see it, so that you, no matter what language you write in, it gets transpiled to JavaScript, but not just JavaScript, AMD. And so the AMD loaders out there, all of them should just be able to consume these languages no matter what they are, as long as there's a transpiler for it. Just a reminder that Node is not exactly CommonJS. There are two probably minor differences, but most people out there are writing their code this way. So the exports object is actually three ways to define it in Node, and that is by decorating it, by substituting the this variable, or by assigning it in whole through the module.exports. So yeah, so what are we going to do? We've got so many different formats here. We've got many flavors of AMD. We've got Node. We've got CommonJS. Which one are we going to pick? And it actually gets a little bit worse because now we've got Harmony coming. How many people are familiar with Harmony? It's a module format that's been proposed, official module format that's been proposed by ECMAScript. Actually, it's still in the process of being proposed. So, but it's only an authoring format. It doesn't handle dependency management. Of course, you can specify what your dependencies are, but there's no way to specify, I want to bundle these together. I want to bundle these together. I want to do more complex things than just bundling everything into one big file. There's no version management defined in there. It doesn't define anything about compilation or concatenation, and it doesn't deal with any of these things we're using plugins for. So it's a great format. It's great. It's official, but it's only solving part of the problem. So, but relax. Like I said, this whole compile to AMD concept basically allows you to just specify that these modules over here are Harmony, these modules over here are CommonJS, and these over here are plain vanilla JavaScript. And the AMD loader will know what to do with these, and if you're requiring one from another, it knows to use the transpiler, and everything just works. So So here's a sneak peek as to what this is going to look like. This actually partially works today, and I'm going to do a little demonstration of it, but it uses different syntax. This is the syntax we're proposing. If you remember from one of my slides that I had up there, from the code demo, that there's this packages configuration definition, and the fun part here is this transform configuration option in packages. And this is not standard. This is something we want to get working and then propose it to the rest of the AMD community. And basically you can provide a pipeline of transforms. And here we show that we're using this commonjs modules 1.1. There's actually a 2.0 that's been proposed. And anything that's under the package node thing is going to use this CJSM 11 plugin. This uses the same exact technology that the plugins work in, but it's going to be used transparently behind the scenes. So, and I've got this other CS thing package here that's written in CoffeeScript, and we don't care at runtime because we can just use this. It's all going to get transpiled. And of course, the build tool will look at the same thing and do this transpiling at build time rather than at runtime. So we're not doing all this computation at runtime. So.
That's pretty cool. I mean, you could imagine building an application where some of it's written in plain JavaScript, some of it's written in ClojureScript, some of it's written in Haskell because there's a Haskell to JavaScript compiler, or maybe you want to write your whole application in Haskell but take advantage of AMD loading, or whatever crazy combination of things you want to put together that makes sense for your application. You could do that.
So I am going to show you
Let's go to
this
terminal.
in action. Okay. Is this the right place?
Other tab.
The tab is just
We'll see that.
Okay. All right. So let me go back to where's our code?
Just close that.
Controller. Not my machine. Oh, there it is. Okay. All right. So here's let's find the controller. Here's the controller, and it's written in this UMD that's compatible with AMD and in Node variant of CommonJS. But there's actually a branch.
Check out.
Thank you. That we created that's in CommonJS. And do I have to do anything? Oh, yeah, here. So this is the naked module here, the CommonJS. You can see the boilerplate is missing from the top, but everything else here looks the same. Except in run.js, I created something here. I want everybody to forget this as soon as you've seen it, because I'm using something that may not work in all of the loaders here. And this is the current syntax, by the way, of how to do these transforms. It's using something called module loader, and next release this is going to be gone. So this is already labeled an experimental feature in here. But just imagine this as transform right now. So transform. We're going to specify transform for this piece of a package here, which is something I also didn't want you guys to see. But there's a piece of this package called app/game. That is going to go through this transform. So let's actually see this work.
Go back to terminal and do npm start.
Thank you. Okay, so we got our web server up and running again, and this is running. And let's cross our fingers. Yes, it's running. So behind the scenes here. Can I get a yes? All right. So behind the scenes, all these same files are loading. And again, before you panic, you do a build during production. You don't need a build during development. And this doing a build during development is awesome because now you've got all your individual files here. So the controller itself, Command O, controller itself. where'd that define come from? This is the compile to AMD. And as you can see here, we automatically provided the 3 commonjs free variables, created the factory function here, and terminated it. And this magic down here is what browsers understand. This specific syntax tells the browser what the file name of this thing that was basically evaluated at runtime, because that's what had to happen here. We needed to fetch this file as text and then run it through the eval function. I know it's evil, but there are use cases for it, to generate this. And of course, this is done at development time. If you're in production, you would run this through a build, and so this would get done during build time. And this pre-wrapping here, this compile to AMD would happen at build time, so that when it came to runtime, it wouldn't have to do all this, and it would just load it as an AMD module. So, is that making sense? Okay. So again, what I just did is I totally took something that was AMD, decided I was going to port it over to CommonJS, and we can look at that again. Yes, we can. So let's see. There were some other modules in there. For instance, REST API. This right here, this whole, how do I look at that? Let's see. Basically, this whole folder here is all CommonJS modules now. And the rest of the application doesn't care. Let me switch back just so we can see what that looked like. Okay, yeah, so we're using the define statement here, and before it said module.exports. So, all right, so let's move on to the next very interesting topic.
You might be thinking to yourself, hey, that's kind of cool because that'll run in Node too. Maybe I could unit test these modules in Node. A little bit of foreshadowing.
Which kind of does dovetail into the next topic, and that is converse to what the JavaScript community is used to, and that is building these huge files because that's what loads most efficiently. We're all for creating things as tiny as possible, and one of the reasons is testing, actually. So the smaller thing you got to test, the way easier it is to test as well. So more reusable, easier to discover because it's in the file system. It's not. I don't know how many times I've been on a project where I've reinvented a function that 3 other people have invented, because it's just things aren't discoverable when they're hidden down in some huge monolithic file. So, of course, there's a hazard when you're working with micro modules, and here's a good example of the hazard. This is right off the Dojo code base, the Dojo editor, which is a very complex component. This is no. I'm not trying to say anything bad, but look at the module list here, and that's just ugly and crazy. Reminds me of a Java import list, actually.
We need AMD dependency list folding now in our editors.
Right. So anyways, but we do have a solution for that, and I think this is a good time to hand it back to Brian. So. Okay, we're going to go through this section kind of quickly, but it progresses nicely, I think, and sort of builds, so I think it'll be relatively easy to follow. So now that we have these modules, right, we're able to create a controller in one file and a REST API in another file, and we've got some syntax that we've seen a little bit of for how to bring it back together. How do we do that? What kinds of things, how do we connect these components back together now that we've, sort of scattered them into smaller pieces and organized them on our file system? We want to build an application. We don't want to build a bunch of tiny files. That's not the point. The point is build an application. So we need to connect them back together. And a lot of times what happened in JavaScript applications is if you imagine your application as a box and line diagram, right? We ended up
taking the lines and actually putting them inside the boxes. And what I mean by that is inside your code you would select some DOM nodes or use a global variable that refers to some other part of your code. Or you would do an event connection using an event library. You would actually write that code in your module. What that equates to is actually taking those lines that you drew in your nice pretty box and line diagram and stuffing them inside the boxes, because now you can't really change those lines independently of the boxes, right? You have to actually go inside the box, modify the code that's in the box to be able to change the connections. But what we'd really like to do is, now that we have these nice modules that are reusable and testable, is find a way to draw the lines without changing the boxes. Put it all back together in a non-invasive, maintainable way. And AMD helps a little bit here. You saw the dependency list. That is one form of connection. It works a lot like Java import statements. Sometimes you need this implementation, you need this class, you need this module. It's just integral to how your component works, and that's fine. That works great for that situation. But there are other times where in Java you would use an interface, right? And you would, in Spring, wire in a particular implementation of that interface because you were solving one type of problem over here. And then you would wire in a different implementation of that interface over here because you're solving a different kind of problem. And you wanted to reuse the component that relies on the interface. You didn't want to write two versions of that. You wanted to write one version and configure it differently for different situations. And we've gotten really good at that kind of thing with Spring and Java. So we know it works well. We want to be able to do it in JavaScript. So here's an example of using AMD dependency. We've got this very simple controller, probably a shopping cart controller, and it's declaring a single AMD dependency on one of Dojo's very nice data store implementations, JSON REST. Okay, and so we create an instance of JSON REST, pointed at a URL. We implement some functions down here, and like all AMD modules, in pure AMD format, we return our controller to define our module. Okay, that's great, but it's the import problem, right? We imported an implementation, a concrete class. We didn't import an interface. So how would you unit test this code? You'd have to actually mock a lot of things. You would have to somehow provide a fake implementation of JSON REST that the loader knows where to find. You'd have to configure your loader to find it. So that might be one approach. You might try to mock the XHR XML HTTP request in the browser. Ooh, that sounds nasty. Do I really want to do that? So it's hard to unit test. Could you use this with another type of store? Maybe you need some other type of data store. Maybe you want to reuse this controller. You can't do it because you're using new, right? And
what if you want offline capability?
Right. What if you want some sort of offline capability? Exactly. What if you even want to use this component with different target URLs? You can't do it, right? We just put too much inside this component. So let's refactor. This is very common, right? Spring users, we do this all the time. We'll just supply our data store implementation in the constructor. Great. Okay, that works a lot better, a lot easier to unit test. We can just create a fake data store, use some spies to make sure the right method is called, and then call add item directly in our unit test. Okay, great. I'm not going to talk about this too much. This is another refactoring, very similar. We're just using a data store property on an object. And we could just set that property instead of supplying it as a constructor. So there are no interfaces in JavaScript, but we sort of accomplish the same thing, right? The interface is implicit. We know there's a data store. It has a certain interface. Dojo's done a good job of defining that interface for us. That's why this works, right? Our code depends on this implicit interface. As long as we can provide that, we can unit test it. All right, but when we put this all back together into a running application, where does the data store come from, right? And your Spring brain goes, boom, dependency injection. I'm going to write some XML. I'm going to instantiate some sort of data store, and I'm going to inject it into my controller. Yes, you're right. You're absolutely right. So that's what we're going to do. This is just a small fragment of something very similar to what we saw with the Monty Hall application. This is, we call it a wire spec because we wrote, we work on Cujo, so we call everything wire specs because wire is the IOC container in Cujo.js. This is similar to XML application context file in Spring. We're declaring a controller or creating an instance of it. And then if you remember from that quick slide that I showed, I just used a data store property, so I can just inject a reference to a data store onto this object as a property. And this is just like in JavaScript saying controller.datastore equals whatever. And down here, I'm also creating a data store. And because Dojo works with AMD, we can just use Dojo modules in here. Digit modules, Dojo modules. Wire will happily instantiate them for you. So create an instance of JSON REST, configure its target property, and then this little bit of magic right here. There's a proposed standard in JavaScript called JSON referencing that allows you to write pure JSON and reference different parts of the document or reference other JSON documents. We've sort of piggybacked on that syntax here to allow you to reference other components in your application context using the same notation. So JSON referencing says the way to define a JSON reference is to use this, an object with a $ref property. So you can think of this, again, in Spring, two beans, one bean being injected into the other as a property. So the cool thing here, right, again, is that these two components know nothing about each other. And we've done the configuration externally. Now, that's great. And JavaScript components working with other JavaScript components is great, especially if you're writing server-side JavaScript. But at some point when you're writing a browser application, you have to touch the DOM. And what we'd like to do is make the DOM a first-class citizen in a dependency injection environment because it's just a fact of life. We can't avoid it. So we want to solve the same kinds of problems, right? We don't want to select DOM nodes within our code when we don't have to because that's the equivalent of using new in our code to create a concrete implementation. We're going to select some concrete nodes using some sort of hard-coded DOM selector like this, right? There's a lot going on here. We've depended on some DOM library. This is probably a concrete implementation of some DOM library that we've depended on. We've depended on its API. We've also depended on this HTML ID, which, as you know, IDs are supposed to be unique within the document. So that makes this just as hard to test as the controller that we saw before, right? We would have to mock somehow the DOM library. We'd have to make it return something. And then even if we could unit test it, we might not be able to use it in very many situations, right? The document would have to have an item with an item list ID. We couldn't use it, somebody changes that, the code is broken. So there's lots of reasons we want to do the same kinds of things with the DOM as we do with JavaScript. And again, the refactor is very easy, right? We just apply our standard hoist it out to the constructor argument or a property. And now our code is much easier to unit test because we can just supply a DOM node. It could be any DOM node. It could even be a fake DOM node, an object in JavaScript that looks like a DOM node, enough to satisfy the testing requirements of this view. Great. And now we can use our IOC container to do the work for us. In this case, Wire comes with various plugins for doing DOM selection. Its base DOM plugin uses the facilities of modern browsers, query selector all and query selector, get element by ID, things like that. But we also have plugins that support the query selector engines of various libraries. If you're already using Dojo, you can choose to use the Wire Dojo DOM plugin, and this will actually use Dojo/query or Dojo.query if you're familiar with the older style Dojo.require. So you get all the goodness of Dojo there, right? You get all the backward compatibility to IE6 and all that happy stuff. So if you're already using Dojo, you can lean on Dojo's selector. If you're already using jQuery, this will lean on jQuery's selector. So you get all of that.
It's fun to note here that Wire DOM will do all the modern browsers, and Wire Sizzle will do all the modern browsers plus the IEs 6 and up. And so it's fun to blow people's minds when they say, well, what did you use? Did you use jQuery or Dojo? We're like, we used neither. So Sizzle actually is the selector engine extracted from jQuery, and it's in its own repo out on GitHub. So we just use that. So.
All right, so if you need compatibility, you can get it. So not only do we need to select DOM nodes, we usually need to listen to events on them, right? Clicks, hovers, things like that. And again, putting the line inside the box, right? This is very typical, right? We select a node with our DOM library with an ID, the button, and then we attach a click handler to it. But again, how would you unit test this? It's even harder to unit test this than the last example, because now you have to provide some fake implementation of this. Maybe it does nothing, and maybe you call this yourself, but you still have to mock this DOM event, right? Because the code inside here is probably going to be dependent on the structure of this DOM event, maybe some properties on it. So again, but that's bad. Whoa, okay, let's refactor. Refactored it to nothing. How does that work? Well, it got considerably easier to unit test, right? There's no AMD dependency, so we don't have to worry about trying to fool the loader into loading some fake implementation. All we have to do is find a way to provide some sort of thing that looks like a DOM event. Okay, that's a lot easier. That's cool. And, it's sort of conceptually better, right? All the controller really cares about is that, hey, now it's time to add an item, right? I don't really care about the DOM so much, the structure of the DOM, because I want my design team to be able to refactor the look and feel of the application without me having to change my code. So conceptually, this is a lot better. And now we can do the same thing. We can apply IOC to hook up DOM events. So we can use, again, we're using a DOM selector from within IOC. This is provided by one of the DOM plugins that we saw on the previous slide. It even lets us do non-ID selectors. We can select the first node that has the class item view. That's great because now we're not using IDs in our HTML.
Standard CSS3 syntax.
Yeah, standard CSS3 selector syntax there. Creating an instance of our controller. And then this on keyword that we saw in the Monty Hall app quickly. And this thing that kind of looks like it's attaching a click event. And in fact, it is. And we're using one of the various Wire on plugins here. Again, we have jQuery and Dojo variants of that. To say, on this DOM node's, on a click event that occurs on a button with the class add that's anywhere inside of this DOM container, when that happens, call my add item function. So if you've used jQuery on or Dojo on, you're familiar with this kind of thing, binding events to containers instead of individual elements. That means that you're free to refactor the elements inside the container, and the events will still bubble up and you'll still catch them, right? So if you move this button around, or you maybe even change it to a different type of element, you can just change this right here, or even remove this, and get the same effect. So it's sort of a nice way to catch events at a higher level. But the takeaway here is that our controller, very simple, And we've done the work of supplying its dependency, which in this case is really the application dependency of an event hookup between a button and the controller that controls it via application composition IOC. Now we have, that was nice because we're communicating via events. We didn't do dependency injection. One thing that frees us from is an API, right? When we inject components, we're now dependent on that component's API, right? Even if it's an interface, which is one form of loose coupling, we can do a little better. The events, you saw how simple the controller was. There were no dependencies, right? It wasn't dependent on any API. It was just dependent on receiving a DOM event from a standard DOM event from the browser. So could we do something very similar to let two or more JavaScript components collaborate? Well, say we had in our shopping cart application our controller that has this add item function. And say we have some other view that's just going to sit in the upper right-hand corner and the count is going to increment whenever we add something to our shopping cart, right? Very simple. We could do it like this, right? We could just inject the count view into our controller, write some code in the controller that calls the increment count method. But we'd like to do better, right? Because then we're dependent on that interface, increment count. Could we just hook these two things together and say, hey, when an item is added, increment the count via IOC? And yes, we can. So we've got our controller up here. I've sort of slimmed it down. The real important stuff is right here. This connect keyword. I didn't put the plug-in here. Apologies for that. There's several plugins in Wire. One of them is Wire/connect. It provides this keyword, connect. And it's basically simplified AOP. We're saying when controller.addItem is called, call my increment count method. And that's all it takes. So now whenever add item is called, increment count will get called. So that's a way for the cart count view to react to an item being added without having to write the code.
And with connect, it passes the same parameters.
It passes the same parameters. In this case, we didn't care about the parameters, so increment count is just going to ignore them, so it works. Do you have a question? Great question. The question was, can we make this conditional? What if add item fails? I'm going to answer that in 2 seconds. I paid him to ask that question. So yeah, that was really nice. It allows lots of nice things. Easier to refactor. In fact, the connection itself can be refactored separately from the components, which is really pretty cool. Wow, I think we heard that. Yeah. So that's a great question. That was a very simplified take on AOP, using AOP to connect two components together. And sometimes that's all you need. But sometimes you need a little bit more. And this should look really familiar to anyone who's used AOP or Spring AOP. We're saying after add item returns, increment the count. So we're being a little more specific here, right? Connect is sort of a little bit nebulous, how it works. In fact, it does something very similar to this. But this ensures that after add item returns successfully, increment count will be called. So what if it fails? Well, you probably guessed, right? You've probably written code like this in Spring. We're going to use another type of advice after throwing. So if add item fails, we're going to do something different, right? We got some other component that's going to show an error to the user or do, recover in some way. So now we've effectively created this, success path and recover from failure path in the IOC container itself without having to modify the controller in any way. We didn't code any logic into the controller. So we don't have to unit test that logic.
Obvious answer probably for the next question. You can change them, right? Like for example, the increment count does something which triggers something else.
Yes.
So the question is, can we chain them?
And what are the consequences?
Sure. And as the application developer, you know, the application level consequences of chaining AOP together, you know, are the responsibility of the application developer. We just ensure, in this case, that, you know, at each step it's behaving as you think it should. You know, it's going to call the next method after it returns, or call the method specified for throwing after it throws.
All at the same time.
Yes. Yes. That's kind of an important point. Since JavaScript is single-threaded, you know, that's going to happen all in the same thread of execution. All right, we're almost there. Got one thing we want to remove from the controller still. We're dependent on a DOM event. That may not seem like a big thing, but if you think about the controller's job here, it doesn't really care about the contents of the DOM event. What does it care about? It cares about the item that needs to be added to the cart. So if we write the controller this way, we have to do some work, right? We have to go find that item somehow, which means we probably need to look at the DOM, right? All we have here is the DOM. So maybe there's an ID or a hash code stuffed into the DOM somewhere, and we have to go find it. But as soon as we write code to go find it, we're dependent on how that ID was put into the DOM, right? So we just shot ourselves in the foot again. This is what we really want to write. Now, how easy would that be to unit test, right? We don't have to mock a DOM event. We just provide an item. This is the core functionality of the controller, and this is what we want to write. So how do we get there? Well, what if the lines in our box and line diagram could actually transform data as things flowed across them? That might be kind of cool, right? Maybe we could transform DOM events into items and do it outside of the controller. And we can. We could go write some very simple module that's just a function whose responsibility it is to capture the algorithm for finding the data item, the item being added to the cart, given a DOM node, or a DOM event, excuse me. So we can take that algorithm out of the controller, encapsulate it in one spot, unit test it, reuse it across our application. So how do we do that? We have a simple syntax for doing that in the IOC container. If we look back at our module, it's just a function, right? Have a new word here, module. We don't need to create an instance of it. It's just a function. So we just want the function itself. Instead of using create, we use module. So we get our function as a component, call it find item. And then down here in our controller, we can actually pipeline functions and methods together. If you're familiar with functional programming, this is essentially function composition. We're saying when a click event occurs on the button inside the item list, call this function. The function will be called with the DOM event because that's what caused us to react in the first place. If you remember from our module, it received the DOM event and it embodies the algorithm for finding the item from the DOM event. So it's going to do its thing and it's going to return a data item to be added to the cart. And that data item is going to be passed to our controller's add item method. So there you have it. A connection that can actually transform the data as it moves through. Yes?
Suppose I need to find it out, right? So can I create a new event at the end of find item and then chain all the other events separately?
The question is, can I fan this out in some way? Currently, there's no syntax that you can use within this string to do that.
An event. I create a new event, then I can have another event handler for add item, another item.
There are other ways to accomplish the fan out, yeah,
Right.
using other types of advice. So yeah, you can accomplish it. We don't have a syntax for that yet.
Yeah, so you could write a little bit of code if you had to anyways to do the fan out and then work from there.
All right. We're in a good spot now. Oh, not quite. Oh boy. Everybody's favorite topic in JavaScript. Add item is probably not some simple function that just stuffs an item into a hash table and returns, right? To do anything interesting, there's probably a server. We probably need to actually send this event off, or send this item off to the server, wait for the response. Was it successful? Okay, increment the count. Did it fail? Then show the error. Oh boy, now we got to write a lot of code to do that. Yeah. I'm going to skip talking too much about asynchrony because of the time. But typically, the way we handle asynchrony in JavaScript is we start modifying our function signatures, right? Uh-oh. Now, I've got a callback in my function signature. Oh, I hate that. Now, somebody has to supply this callback. How does after advice work when there's a callback? Does that even make sense? Okay. Forget that. Let's do something different. I'm going to breeze through this.
This is all the way you shouldn't do it.
Yeah. Right. The essence of the problem is we know we can't do this. Right? This doesn't work in JavaScript because XHR is asynchronous. So we have to do this, which turns into this, which just keeps getting worse. Right? And again, how do you use AOP on functions that take callbacks? It doesn't make any sense. So a lot of things just stop making sense when you introduce callbacks into the mix. So what we would like to do is have something better, right? Some construct that allows us to synchronize on these asynchronous events without using callbacks. And there's, if you've used Java util concurrent future, it's a very similar thing to what a promise is. And a promise allows you to capture the eventual value of an operation and return it as if it was the value. It's a very simple object that kind of acts like an observable piece of data that becomes available later. So you can register to observe it later. But the key is you can return it, right? So now you don't need a callback. You can return something. You can read more about them if you want. The other key thing about promises is that there's actually some proposed standards for them. They're not a part of the language, but because we have standards and because these major libraries have implemented that standard, that not only makes promises convenient for returning values, it makes them an integration point. So if you have Dojo in your application and you want to use the things I'm about to show you, they'll just work.
Does this work with jQuery deferred too?
It does work with jQuery deferred. Thank you, John. Even though jQuery deferred does not quite implement completely the promises A standard, which is one of the standards, it implements enough of it that we can work with it. So, promises A, it's an integration standard. IOC is about gluing things together. Hey, that sounds like a great fit. What if our add item, what if we refactor our add item a little bit and use something like dojo.xhr get that returns a promise already, right? Or a Dojo data store, which returns promises already. We can do the work, lean on that thing. It'll return us a promise. We can return that promise, right? No callback in the signature. We're returning a promise. All right, now we're cooking. Wire's AOP engine is promise aware, which is pretty cool because now you can say, hey, that promise that comes back from add item, after it resolves successfully, that means after the XHR completes, call cartview.incrementCount. And if that promise rejects, which is what happens when the XHR fails. If you've used Dojo data stores or XHR get, you're familiar with this.
Or even
even
jQuery's XHR.
Yeah, $.get.
Yep.
It does the same thing. We can attach advice that will run if that promise rejects. So now we have the same kind of success and fail branch done through the IOC container declaratively, but it's all asynchronous. And now we're really done. Okay, I'm going to turn it back over to John, who's going to talk about code organization and the kinds of things that the stuff we just covered enables.
Very quickly, actually, I think this is one of the things we could probably just breeze through extremely quickly and get on to maybe some more code and some questions. So this is this was an epiphany for Brian. Again, he's full of these quotes because I'm the one that wrote the slide, so I'm quoting him. And that is the file tree on the left actually became useful when we started breaking things down into these micro components. And views were no example. And there's actually a great methodology that we now employ to break up a user interface into these components and how to identify them and stuff. We don't have enough time to talk about that today, but the end result is something you can see right here, is that we've broken this application up into what we like to call just feature areas, because it's really just what are the things that we're talking about when we're talking about the application, and instantly that's like, okay, this is kind of a thing that we should talk about as a thing. So and that just becomes a natural way to break up the application. So in the Monty Hall application, for instance, we had this concept of doors, so we created this door thing. And what's a door thing has? It's got some CSS, and it's got this template that we use. We've got this game concept. We keep talking about a game. What's it have? It turns out it's got a lot of functionality, a lot of JavaScript files in here, a template in there as well. We didn't have any specific CSS for it. We had instructions. We had this marquee that goes at the top. We had this scorecard that we never actually implemented. But it was something. We identified it, and we created a template for it, and we were ready to build it out. So this was like a real big win for both of us, is that now we've got something on the left here that actually makes sense to us. So.
I stopped hiding the left pane of my editor once we started doing this.
All right. So that was that. And I'm going to just quickly look at the view component. Like I said, we've got this methodology that we use to identify what these pieces of the UI are and how to build them and stuff. But basically what it boils down to is that you end up with these views. They've obviously got HTML, they've got CSS, they've got lots of strings and string-like things like date formats and stuff, and then probably a bunch of functionality that goes along with them, and that's where the JavaScript comes in. But important to note is that we also need a way for the CSS/HTML person to be able to build these templates. And if you notice, our templates are, well, I didn't actually show one, but I'll show one, and they're extremely simple. There's no template language in our templates at all. And it is possible to build an extremely sophisticated app with zero template language. But more importantly is that your CSS/HTML person doesn't need to learn a template language. And they also don't even need to learn how to run your application in order to do their work. So I'm going to just show this really quickly. We're going to take a look at the instructions view. And inside the instructions view, we have this thing called harness.html. And this is what the CSS designers, we've employed this in that 300 plus module application with over 100 views. We had over 100 of these test harnesses that the CSS designers could use to actually build out their individual components without running a single line without bringing up some Java JVM. And there's just some boilerplate stuff in here. There's a simple function. And then there's this one function called run test, which is really like the bootstrap. And in an ideal world, we'd have either a parallel one of these or in the same the same file, we would actually have unit tests. And you can run this file in one of two modes. And either would run unit tests on your UI. Yes, you can do that. Or you can, it becomes this sandbox for the designer to use. So, as you can see, we've got this little mini wire spec in here, and this is where you, the engineer, would have to come in and get this thing set up. But it's basically, everything else here is boilerplate, and the only thing that's custom here is this piece. We built a little bit of infrastructure in order to launch these for our CSS designer. And I'm going to skip over that. Come see me later. Maybe this code's going to be available online. You could look it up later. But let's find the thing. Okay, so here is actually it in action. We have this file called launch.html underneath our test folder, and we just give it a URL of that harness file that I showed you, the instructions harness file. And so when we load that,
Go back. I probably.
Oh, got it. Excellent. Okay, so when we load that, it loads our test harness in an iframe, gets everything running, and then we can test. Actually, let me show you what this looks like. This is the part at the bottom down here, this pick-a-door part, which has several states in it. As you can see, it changes. And so our CSS/HTML designer can test this view and see that it's working the way he expects it to work. And these buttons behind the scenes are basically using OOCSS techniques to basically just change some CSS classes in here. And you can see we're using, this is brain dead simple DOM0 JavaScript 101 stuff that our CSS designer can use in order to get this to work. This CSS designer doesn't need to know anything about what we do, the JavaScript engineers, in order to actually work with this harness and then build something that they can use to verify that their little individual component, which is also a new concept for these guys, they're not dealing with pages anymore, they're dealing with little components. Their component, they can test and build it out and then refactor it and just continue to work with it. It's not something that the CSS designer takes and hands over to the engineering and then it becomes this totally separate beast either. So it's a continual thing that they can continue to work with. And of course you can build this out and build higher levels of views that contain views and put those in test harnesses, and they can continue to work with as much as or as little as the application as they like. So
the other thing this does for you, the engineer, is that the CSS designers aren't going to come to you and say, oh, page 2 of the application is broken, and I need to get to page 3 because I need to work on the CSS of page 3, right? They can just pull up the harness for page 3 or some small piece of page 3 and just work on it without any input from you. They don't have to come yell at engineering to fix the app.
Right. So I skipped over the whole unit testing stuff. I'm sure everybody's got a good idea. We favor Buster. It's our favorite. Although we do have Cujo users who are using Jasmine and some other frameworks, I'm sure it's all not news.
Yeah, and I think the takeaway there is that once you have the ability to break your application into tiny JavaScript modules, it just becomes ridiculously easy to unit test it. And it's taking the lessons learned from Java and Spring, small components that are easily unit testable, applying them to JavaScript.
Right. So just to wrap up, we demonstrated all this in Cujo. A lot of this stuff is actually available in other libraries as well, actually in some form or another. But just to wrap up, Cujo.js is a suite of libraries, and these libraries are meant to be used either individually, you can just take a piece of it, or you can use it as a suite. We're actually still working on an easy way, because right now you've got to go grab all the individual pieces and clone them and compose them together yourself. But we are working on what we're calling Cujo Boilerplate and Cujo Bootstrap in order to just launch an entire Cujo application right off the bat. But yeah, for AMD, it's curl and cram, which is the build tool. We saw Wire today. When is the library that Cujo provides to provide the promises. It provides AOP with meld. Poly is the shim to bring up the old browsers up to a more modern standard, and Cola, which we didn't get to demonstrate, is, and it's still in early phases, is what we use for data binding in order to get the DOM to reflect the real-time state of the data. So, and like I said, there are some alternatives out there. Since we're very strong on standards, the AMD standards, there are some other loaders you can use and build tools. This is just a very small example. IOC, there's AngularJS out there. So once you've built this component that expects everything to be injected, you can also use it in the Angular environment. There's lots of promises. A is the standard, Q, Dojo, even jQuery, which isn't the standard, can still be used. And so again, the point of Cujo is not to say you got to use Cujo and that's it. You got to write your code to Cujo, and if you want to go start using something else later, you're stuck. That's not our goal here. Our goal is that your code is your code, and it should be free. So that's why we build everything to standards, and we build things in a way that allows you to do that. So.
And we integrate with a lot of these other libraries,
right,
like Dojo and jQuery.
Right.
You can, if you're already using them, you don't have to give them up.
Right. And we've got a lot of users actually who are using Backbone as their data binding and their MVC framework, and they're not using our Cola, because Cola is alpha. So everything's interchangeable, and we want it to stay that way. So here's where you can find out more information about it. Join the Google group. Encourage your front-end people to do the same. We're very responsive, typically, unless we're at a conference. So it's a great time for questions. I don't actually know if we actually have any time for questions, but thank you.
Thank you. We'll see if we can take a couple if anyone has any.
Yeah. I'll just come up and ask us the questions. That'll be great.
Yeah.
We'll get them posted. There's a place to post slides, right?
Yeah.
Just check back on the website in a week or so.
You bet.